A direct proof is the most straightforward kind of proof. We usually use a direct proof to prove a statement of the form P implies Q. In other words, this means if P is true, then Q is true. So here, P is what's known as the hypothesis, and Q is known as the conclusion. And so we want to show that if the hypothesis is true, then the conclusion is true. And so the idea is simple. We assume the hypothesis, then we use definitions, known facts, and algebra to show that the conclusion Q follows somehow. And so one important point, very important point, let me write this here. Do not assume that the conclusion Q is true. Remember, you want to prove that Q is true. You want to assume P and show that if P is true, then you get that Q is true. So you cannot at any moment just assume Q is true. If you assume Q is true, then of course Q will be true. So there's no proof. But be careful, this is a very common mistake. So do not assume the conclusion. We are trying to prove Q, so we are not allowed to start by assuming Q is true. So the structure is quite simple. Is like we said, we first assume the hypothesis, then we translate the hypothesis using definitions, and then we reason step by step until the conclusion follows. And so this is why definitions matter so much in proofs. If the hypothesis says that an integer is even, for example, we use the definition of even. If the hypothesis says that one integer divides another, we have to use the definition of divisibility. So a direct proof is often the first method to try, and if the hypothesis gives you enough information to work with, then you can usually start there and move directly towards the conclusion.